Good afternoon, all of you. In this lecture, we are going to discuss about hydropower plant. In previous lecture, we discussed thermal power plant. So, in thermal power plant, we were using coal as a fuel, but in hydropower plant, we will use water to generate the electricity. So, hydroelectric power plant. So, what is hydroelectric power plant? Hydro means water. The water which generate electricity, that is called hydropower, hydroelectric power plants. So, these are the contents of my presentation: introduction, working principle, general layout of hydropower plant, main equipments, waste generated and their control, advantages and disadvantages. Objective. So, what are the objective of this lecture? To introduce students to different aspects of power plant. Outcome: the student will be able to understand the principle and working of hydropower plant. Hydroelectric power. Hydro means water. So, hydropower is water power, and hydroelectric power is electricity generated using water power. Potential energy becomes kinetic. This is changed to mechanical energy in a power plant, which is then turned into electrical energy. So, hydroelectric power plant is a renewable resource. So, in hydroelectric power plant, what we do, we use potential energy of power plant, potential energy of water to convert electrical energy. So potential energy of water first converted into kinetic energy, then kinetic energy is converted into electrical energy. So it utilizes the potential energy of water at a high level for generation of electrical energy. So these plants are generally located in hilly areas where dams can be easily made. From the dam, water is led to a water turbine. So water turbine convert the kinetic energy of mm, water into mechanical energy. Then this water is moved to the generator, or the turbine is also connected to the generator. So where mechanical energy is converted into electrical energy. So water energy is used to move the prime mover, which is in the case is potential energy. So hydroelectric power plants. So, the damming of streams and rivers has been an integral part of human civilization from its early history. Controversy paralleled this use because impounding and diverting water for upstream users affects those who live downstream and also modifies the local habits of plants and animals. Dams are built to control floods, improve navigation, provide a drinking water supply, create and enhance recreational opportunities, and provide water for irrigation, other agriculture uses. So, a small percentage of reuse to generate power. Components of the plant and their role in its working. So, there are so many components which is used in hydropower plant to generate the electricity. So, hydroelectricity is produced in a hydroelectric power plant. In this plant, the water is released from a high location. The potential energy of water is converted into kinetic energy. Then this kinetic energy is again converted into mechanical energy. Finally, mechanical energy is converted into electrical energy. So, potential energy of water is converted into electrical energy. So the potential energy present in water is converted into kinetic energy, which is then used to rotate the blades of the turbine. The turbine is hooked to the generator, which produces electricity. So this is the basic diagram of hydropower plant, in which you can see that this is your intake, this is your reservoir, dam, generator, transformer. So what happened actually? A reservoir used to reserve the water. Then dam is always made at height, so so potential energy of water easily can be converted into kinetic energy. So this is your penstoke control gate, and through penstoke water comes to the turbine. or blades of the turbine. Then blades start to rotate, and this turbine is connected to the generator, where turbine after that generator generate the electricity, and this electricity is transferred to the transformer. Transformer is used basically is it's a device which convert uh, one voltage level to another voltage level of electricity. So transformer is then transferred to the powerhouse. Then powerhouse is connected to the power lines. So power lines, through the power lines, electricity can be transferred to the consumer place. So the main components of hydroelectric power plant is the reservoir. So water from a natural water body like a river is stored in the reservoir. This reservoir is built at a level higher than the turbine. Next, the dam. The flow of water stored in the reservoir is obstructed by huge walls of the dam. This prevents the water from flowing and help us harness the energy present in it. So the dam consists of gate present at its bottom, which can be lifted to allow the flow of water through them. The main components of hydroelectric power plant. The most hydropower plants rely on a dam that holds back water, creating a large reservoir. The penstoke. This connects the reservoir with the turbine propeller and runs in a downward inclined manner. When the gates of the dam are lifted, the force of gravity makes the water flow down. The penstoke can reach the blades of the turbine. As the water flows through the penstoke, the potential energy of water stored in the dam is converted into kinetic energy. Next is your turbine. So the kinetic energy of the running water turns the blades of the turbine. The turbine can be either a Peloton wheel model or a centrifugal type. The turbine has a shaft connected to the generator. The main components of hydroelectric power plant. The most common type of turbine for hydropower plant is the Francis turbine, which looks like a big disc with curved blades. A turbine can weigh as much as 172 tons and turn at a rate of 90 revolutions per minute, according to the Foundation for Water and Energy Education. The generator. A shaft run from the turbine to the generator. When the blades of the turbine rotates, the shaft turn a motor which produces electric current in the generator. So the gained magnets rotate past copper coil, producing alternating current by moving electrons. Power lines. The power produced in the generator is sent to various power distribution stations through the power lines. The main component of hydroelectric power plant. So the heart of the hydroelectric power plant is your generator. So most hydropower plants have several of these generators, because without generator you can't generate the electricity. You can convert the potential energy of water into kinetic energy. Kinetic energy can be converted into mechanical energy through the turbine. Then what about electricity? So to generate the electricity you have to connect the turbine to the generator. So what are the environmental impact and drawbacks? Large hydroelectric dams have a number of negative impacts on the local environment and human society. Dams disrupt river ecosystems and migration, killing aquatic life that gets caught in turbine blades. Dams also create artificial reservoirs which flood farmland and forest and displaces wildlife and people. Hydroelectric projects are also susceptible to fluctuations in river flow and rainfall. So, totally, hydropower plants are dependent upon river flow and rainwater. If there is no rainwaters in some areas, you will not be able to generate electricity from the hydropower plants. So, Ghana, which depends on energy from the Volta River Dam, has suffered several energy shortages in recent years because of lack of rainfall. Large dams and reservoirs in tropical regions are important source of greenhouse gases. According to Brazil National Institute for Space Research, Each year, the world dam gives off over 100 million metric tons of methane. So, INP scientists are developing ways to produce energy by burning this methane. Now, there are some advantages of hydropower plant also. So, the advantage of hydropower plant is hydroelectricity is a renewable energy source, which is natural. So, hydroelectricity uses the energy of running water without reducing its quantity. So, there is no harm to use the energy of water to generate the electricity, to produce electricity. So, therefore, all hydroelectric developments of a small or large size, whether run of the river or of the accumulated storage, fit the concept of renewable energy. Advantages of hydroelectric power production and uses. Hydroelectricity contributes to the storage of drinking water. So, hydroelectric power plant reservoirs collect rainwater, which can then be used for consumption or for irrigation. In storing water, they protect the water tables against depletion and reduce our vulnerability to floods and droughts. Hydroelectricity means clean and cheap energy for today and for tomorrow. So there is no pollution in hydroelectrical power plants like a thermal power plant. We have already studied that in thermal power plant, when you burn the coal, there are n number of gases which go into the environment and pollute our environment. Okay, so there is no pollution by using hydropower plants to generate the electricity. So, with an average lifetime of 50 to 100 years, hydroelectric developments are long term investments that can benefit various generations. They can be easily upgraded to incorporated more recent technologies and have low operating maintenance cost. So, hydropower and the environment. Hydropower is non polluting but does have environmental impacts. So, hydropower does not pollute the water or the air. However, hydropower facilities can have large environmental impacts by changing the environmental and affecting lands, use, homes, and natural habitats in the dam area. So, we can summarize the advantages of hydropower plant in this slide. So, in short, we can say the hydropower plant is very efficient, it is cost effective, it is environmental friendly because there is no fumes, no flames, no smokes, no gases are produced, simple in construction and requires less maintenance and has longer life. So, it does not require long starting time like a steam power station. uh, Actually, we have discussed about in thermal power plant that if you want to start, suppose there is load suddenly increases, so it will take time in thermal power plant to start a new unit. But in hydropower plant, there is no long time, no long starting time is required. If suddenly load is increases, you can easily start the hydroelectric power plant. So the hydropower plant also help in irrigation and controlling floods because you make the dam, and dam can be dam water. When hydropower, suppose you are making dam, and suppose you need not required any kind of electricity, so you can close the hydroelectric power plants and that water can be supplied to the irrigation control, sorry, irrigation. And it also control because storing of water in a dam, you can control the flood also. So disadvantages of hydroelectric power plants: high capital cost due to construction of dam. In because dam is very costly, construction of dam is very costly, so it required higher capital cost to construct of dam, but its running cost is not as much as higher like thermal power plant. And transmission cost can be high depending on the location of dam, because almost 90% dams are nearest to river, which is very far from the city or any area where they required electrical energy. So its transmission cost can be high. It will depend upon the area where the hydropower plant is situated. So we can take the one example of pumped storage hydropower plant. You can see that the pump storage hydropower plant. So in pump, what are the advantages of pump storage hydropower plant? In pump storage hydropower plant, the water comes from high level to low level when you required, when you need to generate electricity. But when you don't require any kind of electricity, the water from low lag to reverse to the higher level by the pumped. So this is your pump storage hydropower plant. Now, very important, that how can we calculate the energy which is generating by water. So there are some formulas by which we can calculate the how much efficiency a hydropower plant have, right? Suppose in thermal power plant we calculate the energy efficiency by using uh, two or three formulas. So in hydropower plant we can same we have some formulas by which we can calculate the electrical energy. So what is density? Density is equal to mass upon volume, and weight is equal to mg, mass into gravity, gravitational force. So density of water is equal to 1000 kilogram per meter cube. Hydraulic efficiency into electrical efficiency is equal to overall efficiency. Available hydropower. The power that can be extracted from a waterfall depends upon its height and rate of flow. The available hydropower can be calculated by the following equations. So P is equal to 9.8 QH. So what is P? P is equal to available water power in kilowatt. Q is equal to water rate of flow meter cube per second. H is the head of water in meter. So again you can check the formula. So P is equal to 9.8 QH. So what is power P? P available water power, Q water rate of flow, and head or height of water in meters. So the power which is generated by water is totally dependent of the rate of flow of water and the height where the water is coming from. For example, a large hydropower station has a head of 324 meter and an average flow of 1370 meter cube per second. The reservoir of water covers an area of 6,400 kilometer square. Calculate the available hydraulic power and the number of days this power could be sustained if the level of the impounded water were allowed to drop by 1 meter. So in the question, what is given? The height of the head of the water, which is 324 meter, and average flow of water is 1370 meter cube per second, and the reservoir area is 6400 kilometer square. So first what we have to calculate it? First we have to calculate it the available hydraulic power, the number of days this power could be sustained if the level of the impounded water were allowed to drop by 1 meter. अगर आपका अगर आपको हाइट दी हुई है and the average flow of water is given, so how will you calculate the available hydraulic power? Okay, so the solution is, first we have to calculate the hydropower, available hydropower. by the formula which we have already discussed in this previous slide. So this is the formula for available water power. P is equal to 9.8 QH, where Q is the water rate flow in meter cube per second and the H is the head of the water in meters. So both the value of Q and H is already given in the question. So we can easily calculate the P. So you can see in the solution that the available hydropower can be found using the equation. So P is equal to 9.8 QH and P is equal to 9.8 Q is given, which is, you can see in the example, 1370 meter cube per second, and the head of the water which is given 324 meter per second, 324 meter. So easily you can calculate the power which can be available in hydropower plant, which is 4350 megawatt, right? So you can easily calculate the hydro power by using the formula P is equal to 9.8 QH, right? Now, second thing what you have to calculate it, the area of reservoir is given in the question. So it is asking the number of days this power could be sustained if the level of the impounded water were allowed to drop by 1 meter. So we have to find the number of days, right? So using the 1 meter drop, we find the corresponding volume of water. So volume of water can be calculated by area into height. So area of reservoir is already given, which is 6400 into 10 to the power 6 meter square, and height is your 1 meter. So how much volume will be reduced if 1 meter drop? This will be 6410 to the power 6 meter cube volume. So rate of flow is equal to 1370 meter cube per second. By looking at the units of rate of flow, we can deduce that time in seconds would be volume divided by rate of flow. So the volume unit is in meter cube. You can see from this. The volume is equal to 6400 into 10 to the power 6 meter cube. This is the volume. So you have to calculate the time in number of days. Okay. So rate of flow is already given. So rate of flow, the volume is divided by rate of flow, and you will get the time 4.67 into 10 to the power 6 second, which can be converted into hours, and hours can be converted into days. So finally, the number of days will be 54 days. So you can easily calculate that the available hydraulic power, which the formula was P is equal to QH, where Q is the flow of rate of flow of water and H is the head of water in meter. So it is very easy to calculate the power by this formula. And the second thing is your the number of days the power could be sustained. So you have to find out the time T in seconds. After that, you can easily convert it the second into hours, and these hours can be easily converted into number of days. Next example. A hydroelectric generating station is supplied from a reservoir of capacity 5 into 10 to the power 6 cubic meters at a head of 200 meters. So find the total energy available in kilowatt hour if the overall efficiency is 75%. So A hydroelectric generating station is supplied from a reservoir of capacity 5 into 10 to the power 6 cubic meters, where head is your 200 meters. So find the total energy available in kilowatt hour if the overall efficiency is 75. So you can easily calculate this because in the example, the capacity is given and the head is given and the efficiency is given. So we have to calculate the total energy in kilowatt hour. In last formula, we were calculating the power, which was P is equal to 9.8 into Q into H, which was in megawatt or watt or kilowatt. But in this case, we have to calculate the energy. So what is the energy? What is the unit of energy? The unit of energy is kilowatt hour. So now we come to the solution. The given data is volume and height. So volume is equal to 5 into 10 to the power 6 meter cube and height is given 200 meter. So you know the formula P is equal to power is equal to 9.8 QH for hydroelectric power plant. So Q can be calculated as 5 into 10 to the power 6 meter cube per second. P is equal to 9.8 QH. So Q is equal to 5 point into 10 to the power 6 meter cube per second and H is equal to 200. So it becomes so uh, so it becomes 98 into 10 to the power 8. So if we multiply this by efficiency, you can easily get the energy. So the formula of energy is equal to P into T. We have already discussed that the unit of power is kilowatt and time is in seconds. So the energy which is calculated 98.10 to the power 8 into 10 to the power 3 watt into 1 second into 0.75. So we need to find out the energy in kilowatt hour. So we divide the above value by 3600 into 1000 and get the answer, which is if you calculate this energy by this formula, you will easily get the answer, which is 2.0416 into 10 to the power 6 kilowatt hour. So these are two examples by which we can easily calculate the power which is generating by hydropower plant and the energy. We can also calculate the energy, right? So we have discussed in this lecture the components of hydropower plants, layout of hydropower plants, and uh, and the advantages and disadvantages of hydropower plant, and the energy, how to the energy is calculated by the formula, which is P is equal to 9.8 QH, which is very important. There may be a number of one or two questions may be come into the exam. So now we will come to the classification of hydropower plant. So hydropower plant can be classified according to their ratings. Rating means in megawatt, kilowatt, or watt. So hydropower projects are classified as large as and small hydro projects based on their sizes. Different countries have different size criteria to classify small hydropower project capacity ranging from 10 megawatt to 50 megawatt in India. So hydropower plant of 25 megawatt or below capacity are classified as small hydro, which have further been classified into micro. So we can classify it we can classify the hydropower plant into three categories. One is your small hydropower plant, another one is your micro hydropower plant, and third one is your mini hydropower plant. So the rating of hydropower plant range from hydropower plant is 10 megawatt to 50 megawatt. If your power plant rating is 100 kilowatt or below, then it comes into the category of micro hydropower plant. I can repeat this sentence. The range of hydropower plant is 10 megawatt to 50 megawatt. If a hydropower plant generating the energy which is in the range of 100 kilowatt or below this, these hydropower plant comes into the category of micro hydropower plants. If the hydropower plant, the electricity is generating 101 kilowatt to 2 megawatt, 101 kilowatt to 2 megawatt. If a power plant generates electricity between in this range, then that hydropower plant comes into the category of mini hydropower plant. If the hydropower plant generate the electricity greater than 2 megawatt to 25 megawatt, if a hydropower plant comes into the category from 2 megawatt to 25 megawatt, then these hydropower plant comes into the category of comes into the category of small hydropower plants. So here we can divide the hydropower plants according to their range. And the range of hydropower plant is 10 megawatt to 50 megawatt in India. In other countries, it may be differ. So the estimated potential of 21,135.37 megawatt from 7,135 sites for power generation in the country from small or mini hydral projects is assessed by the Alternative Hydro Energy Center of IIT Roorkee in its small hydro database of July 2016. So the hilly states of India, mainly Arunachal Pradesh, Himachal Pradesh, Jammu and Kashmir, and Uttarakhand, and constitute around half of this potential. So in India, 21,135 approximate megawatt energy is generated by the hydropower plants, in which most of the half of the hydropower plants are situated in Himachal Pradesh, Arunachal Pradesh, Jammu and Kashmir, Uttarakhand, and other hilly stations. So there are many power plants in which I'm going to show you, which is generating very high power. So Tehri Hydropower Complex, it generates 2,400 megawatt. Topping the list of hydroelectric power plants in India is the Tehri Dam in Uttarakhand, the highest hydroelectric power project in the country. Next is your Konya hydroelectric project, which is generating 1,960 megawatt electricity by using the hydropower plant. Third one is your Sri Salem Dam, which is generating 1,670 megawatt through hydropower plant. Another one is your Nathpa Chakri Dam, which is generating 1,530 megawatt, and Sardar Sarovar Dam, which is generating 1,450 megawatt. So these are all power plants come into the category of high generating electricity power plants. It is not small. Generation is very high. First power plant, which is situated in first hydropower plant, which was situated in India. That was that was in Darjeeling, Sidrapong, and it was installed in 1897, and its capacity was 130 kilowatt. So this was the first hydropower plant installation in India, which was in Darjeeling, Sidrapong, and its capacity was 130 kilowatt. So a hydro plant needs a head, different type of turbines like Palatine, Francis, Calpin, etc. are utilized. So we have already discussed that there are different type of turbines which is used in hydropower plants, and it will depend upon the available head, I mean height, to convert the potential energy because of the head to mechanical rotation. Some types like Palatine uses the kinetic energy of water to hit the blades to the turbine to make them rotate. Such turbines are called impulse turbine. So Peloton in it comes into the impulse turbine because some this is uses the kinetic energy of water to hit the blades of the turbine to make them rotate. On the other hand, Francis, Calpin, etc. uses the pressure of water to produce mechanical rotation. Those are called reaction turbines. So there are two type of turbines. One is your impulse turbine, second one is your reaction turbine. Impulse turbine is the example of impulse turbine is Pelton turbine, and the example of reaction turbine is your Francis and Kaplan turbine. So majority of turbine are Francis turbine because can be used a vast range of head because it use pressure of the water to rotate the turbine. Now, once the mechanical rotation or torque is achieved by the turbine, utilizing the head of water, the generator converts it to electrical energy, and generally in such cases, synchronous generators are used. So without generator, hydropower plant is nothing. If there is no generator, you can't generate the electricity without using generator. So generator is the heart of hydroelectric power plants. Now this is the data or this is the graph of different countries where hydropower plant, hydro, uh, where electricity is generated by hydropower plant. So on the top, China is the largest electricity generator of hydropower plants. The orange one is showing the data of 2015, and the other one, this is showing blue one, this one, sky blue. This is showing the data of 2014. This purple is the data of 2013. This green color shows the data of 2012, and this data show the this color show the data of 2011 brick color, and last one blue one shows the data of 2010. So you can easily see that the generation of electricity from hydropower plant is increasing day by day. So you can see that in this country, the highest generation of hydropower plant was in 2015. In Canada, it is almost constant. In Brazil, the highest generation was in 2011. In USA, the highest generation of hydropower plant was in 2011. In Russia, it is almost constant, and the highest generation of hydropower plant was in 2013. Norway, the highest generation of electricity through hydropower plant was in 2012. In India, the highest generation of electricity from hydropower plant was in 2013. So these are the different countries where by this graph you can easily see the generation of hydroelectricity by the using of hydropower plants. So I can summarize now. We can summarize the this lecture that we have already discussed about hydro. What is hydropower plant? The different components of hydropower plant, advantages of hydropower plant, disadvantages of hydropower plant, and the how to calculate the energy which is generated through the hydropower plant, and the different kind of hydropower plants in India. So and different kind of power plants, different electricity generation in different countries by using hydropower plants. So we have already studied the hydropower plant, and the reference book is Electrical Power Generation, Transmission and Distribution by Singh SN, and Generation of Electrical Power by B.R. Gupta. Now, after this lecture, there are some questions. So, after this lecture, you will be able to attempt these questions easily. So, first question is, which of the following is not a requirement for site selection of hydroelectric power plant? Number one is availability of water, large catchment area. Yes, it is required. Rocky land. Yes, it is required. Sedimentation. No, it is not required for hydroelectric power plant site selection. Second question is the amount of electrical energy that can be generated by a hydroelectric power plant depends upon head of water, quantity of water, specific weight of water, efficiency of alternator. So we have already discussed the head of water is very important to generate the electricity. Now, third question is your potential energy of water is used to drive the turbine. Yes, of course, it is true. Third one is your hydroelectric power plant is non-renewable source of energy, conventional source of energy, non-conventional source of energy, continuous source of energy. So we have already discussed that hydropower plant is a renewable energy source. So it is your non-conventional source of energy. Next, hydroelectric power plant is generally located near load centers. Yes, to reduce the cost of transmission line, we can generally located near load centers. Next question is your hydroelectric power plant is mainly located in flat areas, deserts, hilly areas, or deltas. So we have already discussed that in India, most of the hydropower plants are situated in which areas? Uttarakhand, Jammu and Kashmir, Himachal, and some other hilly areas. So what is the requirement of hydropower electric power plant? Is hilly areas. So C is the right answer for this question. Now, which of the following statement is true about hydroelectric power plant? So, hydroelectric power plants are multi-purpose. Due to which of the following statement is true about hydroelectric power plant? Hydroelectric power plants are multi-purpose. Due to non-uniform flow of water, frequency control in such plant is very difficult. Hydroelectric power plant has high running cost. Water is used as fuel in hydroelectric power plant. So, which of the following statement is true? You can easily find out. Next one is your which of the following is not an advantage of hydroelectric power plant? We have already discussed advantages and disadvantages of hydropower plant. So number one, no fuel requirement, low running cost, continuous power sources, No standby losses. So there is no continuous power sources. There may be obviously losses will be exist. No fuel requirement and low running cost. So we have already discussed that its running cost is very low, but its capital cost is very high. So low running cost is the advantage of this. Then which of the following is not an no fuel requirement? This is also the advantages of this continuous power source. This is not the advantage of this because you can't get continuous power from this hydropower plant. Thank you. So we can summarize the hydropower plant. Hydro means water and power means power. So water generate the power by which that is called your hydroelectric power plant. So in hydroelectric power plant, what are the basic concept? The kinetic energy of water, sorry, the potential energy of water is converted into the kinetic energy. Then this kinetic energy again converted into the mechanical energy by using the turbine, and this mechanical energy is converted into the electrical energy. So this is all about your hydropower plant. Thank you.